When an object has rotational symmetry, that means if you rotate by a fixed number of degrees, then the object replicates itself. So let me give you an example of a 72 degree rotational symmetry, and it's the Chrysler symbol. So if you have a Chrysler car or a Dodge, then somewhere on there is maybe on the hood ornament is a pentagon, and I think it's sort of drawn like this. So that's sort of pretty much the Chrysler car symbol. It's a sort of a pentagon type of a star figure. Anyway, you imagine that if you rotated this by 72 degrees, which is 1/5 of a circle, then you would get the same object again. So every time you rotate by that amount, then it turns back to the same object. So there's a rotational symmetry. And in order to rotate, it has to rotate about an axis, a point. And so the center is the point of rotation. So anyway, that's an example of that. And incidentally, this kind of symmetry can be represented by a closed algebraic system called a group. So anyway, I don't, top of my head, I can't remember if I mentioned groups in my book. And but if you studied algebra at an advanced level, you know, at the senior level or graduate school level, at the abstract level, you learn about algebraic systems, which might have a finite number of numbers in them, and they have different kinds of properties that may or may not be like our real number system or integers. And the ones called groups have symmetry, and this actually could represent a group, algebraic group. And so anyway, I'll leave it at that. It's a very fascinating topic if you get into abstract algebra, but it's considerably more advanced for this course than we can, take time to go into. All right, so now we're mainly interested in point symmetry, and let me define a point symmetry. An object which has point symmetry is such that if you rotated it 180 degrees around a point, then it would replicate itself. So I gave an example of one earlier. This function, f of x equals to x cubed minus 9x. And it's one of my more favorite third degree polynomial functions. And so the graph looked like this. And that's a shape you'll learn about in a later chapter called the cubic polynomial shape. It has two turns to it. And this center point here is the point of symmetry. Because if I take the right half of this graph and I rotate it 180 degrees, or a half circle, then I would get the left half. And same over here. If I took the left half, rotated 180 degrees, I would get the right half. So that's an example of point symmetry. Point symmetry. Actually, all graphs of third degree polynomials have point symmetry to them, which is kind of interesting, I think. All graphs of second degree polynomials have line symmetry. So if you find line symmetry in second degree functions, point symmetry in third degree functions, you find it in other functions, but it's a little more limited. It may or may not have those features. And anyway, let me give you another example of point symmetry. And earlier I gave you the cosine wave. The sine wave also has point symmetry. So the sine wave oscillates this way. And the only difference between it and the cosine function I drew earlier is that a sine function crosses to the origin. And so if I took the right half and spun it to the left half, you can kind of imagine that you would get the same thing. So that also has symmetry to the origin. Now when you have point symmetry to the origin, then that's the feature we're going to call an odd function. And that can be flushed out by using a little algebra technique. So we'll study that later on. But anyway, let me give you one other example of point symmetry. And this too will be symmetric to the origin. Let's see, how about y equals to 1 over x, or f of x equals 1 over x, if you write it with function notation. Okay, this graph is a hyperbola, and it looks like this. And we usually draw it with dashed lines. And these lines, people call them dotted lines, but I find myself drawing dashed lines. So I call them dashed lines instead of dotted lines, but these lines are called asymptotes. So we'll learn about that later also. But so the hyperbola is kind of a funny looking function. But if you took the right half, for example, and rotated it 180 degrees, it would turn into the left half. So it too has point symmetry to the origin. So anyway, it's good to know distinguish these two kinds of symmetry that we're interested in terms of functions, and later we'll learn how to recognize those through the algebra. So we're kind of building on what we know about functions, just making some observations about them. And so first we have to be able to define what a function is. Now we just looked at its symmetry, and next we'll look at domain and range of functions. So we'll just keep building on our knowledge.